In this video, we are going to solve one question that will help us to see the different applications of matrix and determinant. The question is this: if matrix A equal to this 3 by 3 matrix, if matrix B is a 3 by 3 matrix such that A times B minus A inverse equal to twice of matrix A times adjoint of A, then what is the value of matrix B? First, let's express adjoint of A in terms of A inverse. We know that A inverse equal to adjoint of A divided by determinant of A. Multiplying both sides of the equation by determinant of A gives us adjoint of A equal to A inverse times determinant of matrix A. So, twice of A times adjoint of A equal to 2A times adjoint of A means A inverse times determinant of A, which is equal to 2 times matrix A times A inverse gives us identity matrix times determinant of A. Hence, let's take the given equation, that's AB minus A inverse equal to 2A times adjoint of A, and rewrite it by substituting 2 times identity matrix times determinant of A in place of 2A times adjoint of A, and taking A inverse to the right of equality sign. That's AB equal to twice of identity matrix times determinant of A, taking minus A inverse to the right of equality sign gives us plus A inverse. To write matrix B in terms of matrix A and A inverse, we have to remove matrix A from here. We can't divide both sides of the equality by matrix A because we don't have the rule for division of matrix. The multiplicative inverse of matrix A is A inverse. So, to remove matrix A from the side of matrix B, we have to multiply both sides of the equality by A inverse. That's A inverse times A times B equal to A inverse times twice of identity matrix times determinant of A plus A inverse. This implies A inverse times matrix A gives us identity matrix times matrix B equal to A inverse times twice of identity matrix times determinant of A plus A inverse. Identity matrix times matrix B is simply matrix B equal to A inverse times twice of identity matrix times determinant of A plus A inverse. So, the formula for matrix B is matrix B equal to A inverse times twice of identity matrix times determinant of A plus A inverse. Thus, to solve for matrix B, we have to find A inverse and determinant of matrix A. Let's determine A inverse first. We know this general formula. Matrix A times identity matrix is always equal to identity matrix times A inverse. Meaning, if we switch matrix A and identity matrix, the new matrix we will find is inverse of matrix A. To apply this formula, let's form an augmented matrix and set elements of matrix A to the left of the vertical bar and a 3 by 3 identity matrix to the right of the vertical bar. What's next is to carry out elementary row operations that will help us to convert each column of matrix A to the corresponding column of identity matrix. Let's start with column 1. To convert this 2 to 1, we have to multiply row 1 by 1 over 2. Elements below first entry have to be converted to 0. To convert this negative 2 to 0, we can add it with this positive 2. So the formula that can convert this negative 2 to 0 is row 1 plus row 2. We have 2 and negative 2 above this one. Rather than multiplying either 2 or negative 2 by 1 over 2, it's advisable to multiply 1 by 2 and then add it with this negative 2 in order to make it 0. So the formula that can convert this 1 to 0 is 2 times row 3 plus row 2. Multiplying row 1 elements by 1 over 2 gives us 1, 0, negative 1 over 2, 1 over 2, 0 and 0. The sum of row 1 and row 2 gives us 2 plus negative 2 equal to 0, 0 plus 3 gives us 3, negative 1 plus 0 equal to negative 1, 1 plus 0 is 1, 0 plus 1 is also 1, and 0 plus 0 equal to 0. In casting forward to row 3, 2 times 1 is 2, 2 plus negative 2 equal to 0, 2 times 2 is 4, 4 plus 3 gives us 7, 2 times negative 1 is negative 2, negative 2 plus 0 gives us negative 2, times 0 is 0, 0 plus 0 equal to 0, 2 times 0 is again 0, 0 plus 1 gives us 1, 2 times 1 is 2, 2 plus 0 equal to 2. Next, we have to convert this column 2 elements to the form similar to column 2 elements of the identity matrix. Unfortunately, this 0 is what we need it, so no operation is needed in row 1. To convert this 3 to 1, we have to multiply row 2 by the reciprocal of 3, that's 1 over 3. To convert this 7 to 0, we have to add it with negative 7. To get negative 7, we have to multiply this 3 by negative 7 over 3. Thus the formula that can convert this 7 to 0 is negative 7 over 3 times row 2 plus row 3. Let's copy row 1 elements as they are. Multiplying row 2 elements by 1 over 3 gives us 0, 1, negative 1 over 3, 1 over 3, 1 over 3, and 0. When we move to row 3, negative 7 over 3 times 0 equal to 0, 0 plus 0 equal to 0, negative 7 over 3 times 3 equal to negative 7, negative 7 plus 7 equal to 0, negative 7 over 3 times negative 1 equal to 7 over 3, 7 over 3 plus negative 2 equal to 1 over 3, negative 7 over 3 times 1 equal to negative 7 over 3, negative 7 over 3 plus 0 equal to negative 7 over 3, negative 7 over 3 times 1 equal to negative 7 over 3, negative 7 over 3 plus 1 equal to negative 4 over 3, negative 7 over 3 times 0 equal to 0, 0 plus 2 equal to 2. At last, we have to convert this column 3 element to the form similar to column 3 elements of the identity matrix. To convert this negative 1 over 2 to 0, we have to add it with positive 1 over 2. If we multiply this 1 over 3 by 3 over 2, it will give us positive 1 over 2. Thus, the formula that can convert this 1 over 2 to 0 is 3 over 2 times row 3 plus row 1. To convert this negative 1 over 3 to 0, we can add it with this 1 over 3. Hence, we can use the formula row 3 plus row 2 to convert this negative 1 over 3 to 0. To convert this positive 1 over 3 to 1, we have to multiply row 3 by 3. 3 over 2 times 0 is 0. 0 plus 1 equal to 1. 3 over 2 times 0 is again 0. 0 plus 0 is 0. 3 over 2 times 1 over 3 equal to 1 over 2. 1 over 2 plus negative 1 over 2 equal to 0. 3 over 2 times negative 7 over 3 equal to negative 7 over 2. Negative 7 over 2 plus 1 over 2 gives us negative 6 over 2, which is equal to negative 3. 3 over 2 times negative 4 over 3 equal to negative 2. Negative 2 plus 0 gives us negative 2. 3 over 2 times 2 equal to 3. 3 plus 0 gives us 3. Adding row 3 and row 2 elements gives us 0 plus 0 equal to 0. 0 plus 1 equal to 1. 1 over 3 plus negative 1 over 3 equal to 0. Negative 7 over 3 plus 1 over 3 equal to negative 6 over 3, which is equal to negative 2. Negative 4 over 3 plus 1 over 3 equal to negative 3 over 3, which is equal to negative 1. 2 plus 0 equal to 2. Multiplying row 3 elements by 3 gives us 0, 0, 1, negative 7, negative 4, and 6. Now, the identity matrix comes to the front. Hence, the matrix to the right of the identity matrix is A inverse, meaning A inverse is this 3 by 3 matrix. The other unknown that we have to determine is determinant of matrix A. To find the determinant of this matrix, let's choose row 1 elements as the coefficient of the 2 by 2 matrix we are gonna form and assign their signs as positive, negative, and positive. The sign of 2 is positive, hence 2 times the determinant of the first 2 by 2 matrix. The second coefficient is 0, so no need to include it in the calculation because 0 times any number is 0 and adding or subtracting 0 doesn't bring any change in the final result. That's why we choose this row 1 element as the coefficient of the 2 by 2 matrix we are forming. The sign of negative 1 is positive. Positive times negative gives us negative, meaning minus 1 times the determinant of the third 2 by 2 matrix. To determine the element of the 2 by 2 matrices, we have to cross out the row and column containing the coefficients. This 2 is in row 1, column 1. Removing them left us with these 4 elements. This negative 1 is in row 1, column 3. Removing them gives us these 4 elements, which is equal to 2 times 3 times negative 1 minus 2 times 0 minus 1 times 2 times negative 2 minus 1 times 3, which is equal to 2 times 3 times negative 1 is negative 3, 2 times 0 is 0, negative 3 minus 0 gives us negative 3, minus 1 times 2 times negative 2 is negative 4, 1 times 3 is 3, negative 4 minus 3 gives us negative 7, 2 times negative 3 gives us negative 6, negative 1 times negative 7 gives us positive 7, negative 6 plus positive 7 equal to 1. Thus, determinant of matrix A equal to 1. Now, we can solve the expression inside the bracket because we already know A inverse and determinant of A. For ease of explaining it, let's designate the expression inside the bracket by matrix C. That's matrix C equal to 2 times identity matrix times determinant of A plus A inverse, which is equal to 2 times identity matrix is this 3 by 3 matrix times determinant of A is 1. 1 times the matrix is the matrix itself plus A inverse is this 3 by 3 matrix. This implies matrix C equal to 2 times identity matrix means making the main diagonal elements 2 plus A inverse. Addition of 2 matrices means adding the corresponding elements of the matrices. Except main diagonal elements, all other elements of this matrix are zeros. So the addition brings a change only on the main diagonal elements of A inverse. 2 plus negative 3 is negative 1. 2 plus negative 1 is positive 1. 2 plus 6 is 8. At this stage, we can solve matrix B by multiplying A inverse and matrix C, meaning matrix B equal to A inverse times twice of identity matrix times determinant of A plus A inverse, which is equal to A inverse times. We already designate the expression inside the bracket as matrix C, which is equal to A inverse is this 3 by 3 matrix, and the designated matrix C is this 3 by 3 matrix. To find row 1, column 1 entry, we have to multiply row 1 of A inverse with column 1 of matrix C. Negative 3 times negative 1 plus negative 2 times negative 2 plus 3 times negative 7. Row 1, column 2 element is the product of row 1 of A inverse with column 2 of matrix C. Negative 3 times negative 2 plus negative 2 times 1 plus 3 times negative 4. To determine row 1, column 3 entry, multiply row 1 of A inverse with column 3 of matrix C. Negative 3 times 3 plus negative 2 times 2 plus 3 times 8. To find row 2, column 1 entry, we have to multiply row 2 of A inverse with column 1 of matrix C. Negative 2 times negative 1 plus negative 1 times negative 2 plus 2 times negative 7. Following the same analogy, we can find the other elements as row 2, column 2 entry is negative 2 times negative 2 plus negative 1 times 1 plus 2 times negative 4. Row 2, column 3 entry is negative 2 times 3 plus negative 1 times 2 plus 2 times 8. Row 3, column 1 entry is negative 7 times negative 1 plus negative 4 times negative 2 plus 6 times negative 7. Row 3, column 2 entry is negative 7 times negative 2 plus negative 4 times positive 1 plus 6 times negative 4. Row 3, column 3 entry is negative 7 times 3 plus negative 4 times 2 plus 6 times 8. Negative 3 times negative 1 is positive 3 plus negative 2 times negative 2 is positive 4 plus 3 times negative 7 is negative 21. 3 plus 4 plus negative 21 gives us negative 14. Negative 3 times negative 2 equal to 6 plus negative 2 times 1 equal to negative 2 plus 3 times negative 4 equal to negative 12. 6 plus negative 2 plus negative 12 equal to negative 8. Negative 3 times 3 equal to negative 9 plus negative 2 times 2 equal to negative 4 plus 3 times 8 equal to 24. Negative 9 plus negative 4 plus 24 equal to 11. Negative 2 times negative 1 is positive 2 plus negative 1 times negative 2 is again positive 2 plus 2 times negative 7 is negative 14. 2 plus 2 plus negative 14 equal to negative 10. Negative 2 times negative 2 is positive 4 plus negative 1 times 1 is negative 1 plus 2 times negative 4 is negative 8. 4 plus negative 1 plus negative 8 equal to negative 5. Negative 2 times 3 is negative 6 plus negative 1 times 2 is negative 2 plus 2 times 8 is 16. Negative 6 plus negative 2 plus 16 equal to 8. Negative 7 times negative 1 is positive 7 plus negative 2 times negative 4 is 8 plus 6 times negative 7 is negative 42. 7 plus 8 plus negative 42 equal to negative 27. Negative 7 times negative 2 is positive 14 plus negative 4 times 1 is negative 4 plus 6 times negative 4 is negative 24. 14 plus negative 4 plus negative 24 gives us negative 14. Negative 7 times 3 is negative 21 plus negative 4 times 2 is negative 8 plus 6 times 8 is 48. Negative 21 plus negative 8 plus 48 gives us 19. Therefore, matrix B is this 3 by 3 matrix. I know it's lengthy and tedious, but solving this kind of problem helps you to master your knowledge on the subject matter. This brings the end of part 18. If you have any unclarity, please don't hesitate to jot down on the comment section. Have enjoyable time. Bye bye.